Hi, I'm Michael Pfeiffer, Principal Consultant and Trainer at Industrial Metallurgists. Today I'm going to talk about how metals engineering fits in to help make better, lower-cost products while helping people improve their productivity and reducing stress. So I'm a metallurgical engineer. I have a bachelor's and master's in metallurgical engineering and then a PhD in material science and engineering. And for over 30 years, I've been working as a metals and materials engineering, both working in manufacturing and in product design for a company. I worked for Motorola and then on my own, doing the same things I did at Motorola, helping with product design and manufacturing with various clients. So when I first started working, I was working as a process engineer in a manufacturing facility. I was responsible for sustaining manufacturing processes and for making process improvements. And a lot of what I did had to do with evaluating materials, looking at the materials we were using in our manufacturing processes, and understanding the effects of the manufacturing processes on the materials that on the components we were producing, in order to make sure that the components we were producing had the right properties, also the right composition and the right microstructure, so that they would perform as needed in the product. And so, in addition to doing process development and making process improvements, I was also responsible for fixing things when something went wrong with the process, and understanding the effects of the equipment and the equipment process parameters, and the process parameters on the output that we were creating, and figuring out what went wrong when problems would occur. So that would involve failure analysis. I also was involved in writing specifications for manufacturing processes, to make sure that people were running the processes properly, so that the things we were creating had the right properties and right microstructure. And then from there, I went into working in product design. It was part of the Motorola Automotive Electronics Group, where I was part of a materials engineering group where we were responsible for helping designers select materials for components for new products, helping perform reliability tests on materials to understand how they would perform in new environments, working with suppliers to improve their quality, so that when they would send us components, they would have the right composition and microstructure and properties, and also working with our manufacturing and assembly line, and also our suppliers, to help with improvements for help making improvements to their manufacturing processes and assembly processes, so that the materials coming out had the right properties. Occasionally that would involve doing failure analysis on components. I was also involved with writing specifications for materials for putting on component prints, to make sure that suppliers understood what they had to do to make sure that the materials they were providing to us, met our specifications, so that they would perform as needed in the product, for both performance requirements as well as reliability requirements. And as part of that also is working with the design engineers to help optimize the materials that are being used in the products, or in the components. Quite often that there would have to be some sort of optimization between the materials being used and the shape of the component, and also the material being used, to come up with the optimum design that would result in the component meeting the performance and reliability requirements at the lowest possible cost. And meeting performance requirements would mean, could be strength or electrical conductivity, and then for reliability, it could be fatigue resistance or corrosion resistance were the primary reliability concerns. So there are a lot of areas where metals engineering and materials engineering fits in with product design and manufacturing, and I was lucky to be involved with all of them. And so now I'm doing that with clients with clients all over the country, and actually all over the world. So in this discussion, I'm going to explain how metals engineering fits in to help make better, lower cost products while helping people improve productivity and reducing their stress. So we can apply materials engineering to design lower cost components. Lower cost components comes in some different ways. One is just selecting materials that are lower cost. That's one way. Also, we want to select materials that enable components to be easily manufactured, so the cost of fabricating the components is low. And also select materials that enable components to be joined easily, and that helps keep assembly processes low. When we use materials that are difficult to use in component fabrication or assembly, then that results in an increase in the costs because there's more time and attention required to produce components and to produce the assemblies. So design for manufacturability and design for assembly is important for keeping costs low for components. Materials engineering also fits in with improving product reliability. It's important to select materials that can withstand exposure to the use conditions without degrading to the point that components and joints fail. And with where metals engineering fits in with design then is helping to identify first of all, identifying the conditions that the materials will be exposed to during product use. And there are a lot of different sources of stressors that can cause degradation. And then identifying materials that can be used, and also looking at the design, just the mechanical design, and understanding what things that can be done with the mechanical design to help reduce the effects of the stressors. And together between the mechanical form as well as the materials, identifying what can be done from a design perspective to improve product reliability. And oftentimes this the work in looking at product reliability has to be done in parallel with other design efforts, so that by the time the product testing comes around, we can pass the testing as pass testing and meet product development schedules. So improving product reliability also means meeting product reliability requirements and meeting the development schedules. Also meeting development schedules means evaluating potential suppliers of components and assemblies and making sure they have the capabilities of producing materials that consistently meet requirements. So meeting product development schedules means passing testing the first time and helping to make sure and evaluating suppliers to make sure that they're capable of providing materials and components consistently to meet launch schedules as well as product shipment schedules. You can also apply materials engineering to innovate. This applies to both design and manufacturing. Looking for different materials or the way that they're conditioned from a mill, maybe hot rolled versus cold rolled, or annealed or normalized. Taking advantage of the mill condition along with the material and then using heat treating afterwards or using a coating afterwards, all of those things together enables using different materials or different conditions of materials and different coatings to develop components and designs that have maybe lower cost or improved performance or improved reliability that help provide a competitive advantage compared to your competitors' products. And the same thing applies to manufacturing. It's developing manufacturing processes that consistently produce components and assemblies that meet your requirements, and doing that at low cost to help provide a competitive advantage from a cost perspective and the ability to meet shipments. You can also apply materials engineering to improve manufacturing quality by developing manufacturing processes capable of producing materials and components and assemblies that where the materials have the properties and the composition necessary to meet the performance and reliability requirements for the component. And being able to do that consistently means over and over again, and be able to do it quickly as well. And finally, we can apply materials engineering to quickly determine the root cause of product failures, manufacturing quality problems, and broken production equipment. With product failures, we want to figure out what happened and put things in place to prevent the problem from reoccurring. And this can be either with products that are failing during testing or during use. We don't want product problems to linger, and by not doing a failure analysis and just getting in rooms and talking about the problem, that's not getting the information needed to understand, to get to the root cause. We have to do the failure analysis to understand metallurgically what happened, and then from that information we can help determine the root cause. And the same thing applies to manufacturing quality problems and broken production equipment. We need the information from a failure analysis, and then to understand that information and understand the metallurgical cause of the problem in order to identify the root cause of the problem. And without doing a failure analysis, problems just linger, and either our customers get angry with us, or we're not meeting shipments, or costs just increase. So, and finally, by doing all those things, we can, in applying metals engineering, people can be more productive and they can be less stressed while still meeting their product development schedules and meeting manufacturing schedules. So there are a lot of ways where metals engineering fits in to make improvements as well as to enable people to be more efficient and have be able to enjoy their job more and have less stress. So if you want to incorporate metals engineering into your engineering process, the first thing is to realize when metals engineering expertise is needed. And one clue is that you're spinning your wheels, your problems are still lingering, and you're starting to deal with problems, and maybe your manufacturing line is limping along, or your products are not passing their tests, and you're having to repeat tests over and over again, and product launches are delayed. And the second step is to either get training or get help. Learn metallurgy or get help from a person who's got metallurgical engineering expertise. So that's it. If you have any questions, feel free to email or call. Also check out our website. There's lots of different blogs and articles and podcasts for information about metals engineering and how metals engineering applies to product design and manufacturing. Thanks for watching. Bye.